Stop worrying about homework and start learning with confidence. This is AskLearn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So here we're going to say that the plus direction is horizontal to the right. And then we can say our plus y is vertical up. We know this would be for part A. We know that the magnitude of the applied force is 100 newtons, and so we can say that the x component of this force, which in the textbook is denoted as F sub h. F sub h simply means the horizontal force, so h just stands for horizontal. I would say it's better to denote it as F sub x because x is referring to the Cartesian axes and not simply just horizontal or vertical. So this would be equal to F, the magnitude of the force, times cosine of theta. And we know that this is going to be 100 newtons because the entire force in this case would be in the x direction. So here we can say that there is no vertical acceleration. So we can apply Newton's second law for part B and say that Fn plus force in the y direction would equal mg. And we can then say force normal would equal mg minus the force sine of theta. However, here we have a mass of 25 kilograms, so we can actually just multiply 25 kilograms times the acceleration due to gravity. And we find that the force normal in part B is 245 newtons, given that theta equals 0 degrees. If theta equals 0 degrees, we can eliminate this term. And of course, again, the force normal would simply equal the weight. However, for part C now, we have an angle of 30 degrees. So when we have an angle of 30 degrees, now we actually do have to account for the angle. And so the x component of the force, or we can say again F horizontal, would be the magnitude of that force cosine of theta. We can say that this is going to be equal to 100 newtons times cosine of 30 degrees. And this is giving us 86.6 newtons. For part D, again, the angle is 30 degrees. And now we're trying to solve for the force normal. We can use the exact same formula, and we can say that the force normal would then equal mg. Here it would be minus the magnitude of the applied force times sine of 30 degrees. So this would be 25 kilograms multiplied by 9.8 meters per second squared, minus 100 times sine of 30 degrees. So our force normal here would be 195 newtons. For part E now, theta equals 60 degrees. And we can say that the horizontal component, which would equal F sub x equaling F sub h, is equaling 100 newtons, again, times cosine of 60 degrees. This is equaling essentially 50.0 newtons, given that cosine of 60 is 1/2. And for part F, the force normal would be equal to mg minus F sine of theta. Again, we're using the exact same relationship. So 25 kilograms multiplied by 9.8 meters per second squared, minus 100 newtons times sine of 30 degrees. So here, our force normal equals 158 newtons. Now, for part G, we need to find the condition for the chair to slide. essentially this would mean that the x component of the force would be greater than the maximum static force of friction, which would be equal to the coefficient of static friction multiplied by force normal. We know that here the coefficient of static friction would equal 0.42, and for theta equaling 0 degrees, we have that the force in the x direction would equal 100 newtons. This would be actually less than the maximum force of friction static, which would equal here 0.42 times 245 newtons, 245 newtons, and this is equaling 103. So it's just below the maximum static frictional force. So for part G, we can say that for theta equaling 0 degrees, we can say crate remains at rest. For part H, however, we're doing the exact same thing. Theta is equaling 30 degrees. We know that here F sub x would be equal to 86.6 newtons. This would actually be greater than the force of friction static max, which would be equal to 0.42 times the force normal of 195 newtons. This is giving us 81.9 newtons. Of course, 81.9 newtons is less than 86.6 newtons. So here, the crate slides. And then for I, we know that theta equals 60 degrees. And we can say that here, and this is going to be less than the force of friction static max, which would be equal to, again, the coefficient of static friction, 0.42, multiplied by 158 newtons. This would equal 66.4 newtons. 66.4 newtons is, of course, larger than 50 newtons. So here, crate remains at rest. So part H with an angle of 30 degrees is the only case where the crate will slide. That is the end of the solution. Thank you for watching.